Hello and welcome to part 5 of the Introduction to Differentiation series. In this video, we're going to be looking at when is a function increasing and when is a function decreasing, what exactly is meant by increasing and decreasing functions, and how to find the interval for which the following function is decreasing or increasing. So let's start by recalling something from the previous video, which, by the way, I'm going to leave a link on the top right corner to go and watch it. The previous video, we talked about that when we have a function, we can have points which are called critical or turning or stationary points. These are points where the gradient is 0, the slope is 0, or the slope of the tangent at this point is basically 0, so the tangent is a horizontal line. So this is the turning point. We know that the slope is 0, and since the first derivative is the slope, so the first derivative is the slope or gradient, so the first derivative is also 0 at those turning points. In this video, we want to take a look at the intervals where we don't have a turning point. Like, let's say this interval right here. What's happening? We know that the graph is going this way, so we have a negative gradient over here. And very simply, whenever we have a negative gradient, we say that the function is decreasing. So, you know that all of this interval right here has a negative gradient until we reach a gradient of 0, and then we turn, hence a turning point, to a positive gradient. So m here is positive, and hence this interval, this right interval over here, is called an increasing part of the function. So basically, all I want you to know is that increasing function, or the function is increasing when the slope is positive. That means when the first derivative is positive, and the function may look something like this, or like this. They're all having positive gradients. And on the other hand, when the function is decreasing, the slope or gradient is negative, and hence the first derivative is negative, and we have a function that looks like this, or this. They all have at any point negative gradients. So some functions have an interval where the function is increasing, where it has a positive gradient, and an interval where it's decreasing, having a negative gradient. So let's take a look at how we can find those intervals. So let's start by solving an example. Let's say we have a function y equals x squared minus 2x minus 15, and we're asked to find the intervals where the following function is increasing slash decreasing. So we know that the point where it flips is usually a turning point. So let's start by actually finding where is the turning point. So just like last video, the first thing we need to do is to get the first derivative. So differentiation of this expression is 2x minus 2. And then we equate this first derivative to 0 to find the x's where turning points are. So we add 2, so 2x equals 2, then divide by 2, x equals 1. So this is the x where I have a turning point, or I have a gradient of 0, which is not increasing nor decreasing. It's just 0. So let's draw a small number line and say that this is our x equals 1, where the gradient here is 0. Let's test the gradients on the right hand side of 1 and to the left hand side of 1, and let's see how they are. So let's take any value to the right side of 1, so 2, and let's put this 2 in the first derivative to see if the gradient is going to be positive or negative at that side. So 2 times 2 minus 2, this is basically 4 minus 2, which is equal to 2. So I got a positive value, so I know that the gradient over on this side is positive, thus the function is increasing on this side. And let's test another um, value of x to the left of x equal 1. So let's test 0, for example. So we have a 2 times 0 minus 2. That is going to be 0 minus 2. And this is going to give me a negative 2, which is a negative answer. So I know that the slope here is a negative slope. Hence, this part of the function is decreasing. So we know that this part of the function probably has a gradient that looks like this. And then at x equals 1, we have a horizontal line, and then we start to increase again. This tells me that this point over here is a minimum point. So this is another test alternative to the second derivative test. It's called the first derivative test. However, I prefer to use the second derivative test as shown in the previous video, and that's what I recommend. So answering the question, the intervals where the function is decreasing is going to be all of this part until x equals 1. So basically, decreasing is from negative infinity to 1. And then it starts to increase from 1 all the way to the right. So 1 to positive infinity. And that is my answer. Right. Let's take another example. Let's say we have y equals 3 plus 10x minus 8x squared, and we're asked the same question. So let's find the first derivative. Derivative of 3 is 0, 10x is 10, and minus 2 times 8 is 16x. This is my first derivative. Let me equate it to 0. I'll add 16x, add 16x. So I'll have a 10 equals 16x, which means that my x is 10 over 16, or basically 5 over 8. If you convert that to decimals, you'll get a value of 0.625. So this is the turning point. This is the point where my gradient is 0. So let's do our number line. So we have this point where x equals 0.625, and we are going to do the same as we did for the previous example. Let's test a point to the right of our turning point. Let's say x equals 1, and let's see what happens. So y dash is going to equal 10 minus 16 times 1, and I know that 10 minus 16 is negative 4. So in this part, I have a negative m, or negative gradient, so this part is decreasing. And let's test a value over here. Let's take x equals 0. So I know that my y dash is going to equal 10 minus 16 times 0. So this is gone, so my answer is 10. So it's a positive answer. So this part is a positive slope or positive gradient. So this part over here is increasing. To write my interval, I will know that my function is increasing from negative infinity all the way to 0.625. So negative infinity to 5 over 8, or 0.625. And it's decreasing from 5 over 8, or 0.625, to positive infinity. So here I can tell that my function was increasing, so it was probably having a positive slope and then a 0 slope, and then it came down. So this gives me a hint that this point over here is a local maximum. Let's take a look at another example. Let's say we have y equals 10 plus 2x squared minus 4x cubed. So as usual, let's start by getting our first derivative. 10 is 0, 2 times 2 is 4, 2 minus 1 is 1, minus 3 times 4 is 12, x, 3 minus 2 is 2, so it's 4x minus 12x squared. Let's equate that to 0. So I can take a 4x out common from here. I'm going to have 4x divide 4x, that is 1. I'm going to have negative 12x squared divide 4x, that is 3x equals 0. So here I can see that I have two values for x, which will make this 0 when 4x equals 0. So divide by 4, and we know 0 over anything is 0. So x equals 0, that's my first critical point. And my second critical point is when 1 minus 3x equals 0. So I will add 3x to both sides. So 1 equals 3x, divide by 3, divide by 3. So x equals 1 over 3. That is the second turning point, or this is 0.333. Okay, so let's draw our number line and put those two values. So we know that we have a turning point at x equals 0, and we have a turning point at x equals 0.333. So let's check on each interval. Let's start by the furthermost left interval. So let's take a value to the left of 0. Let's take -1 and substitute it in y dash. So y dash equals 4 times -1 minus 12 times -1 squared. So this is -4, and then -1 squared is +1 times -12, that is -12. So this is going to give me a negative answer. So this part here is negative, so it's decreasing. Let's test a point over here, not to the right of 0. We need to take care that this interval is from 0 to 0.333. So let's choose carefully. I know that 0.1 is in between of 0 and 0.333. So let's say y dash equals 4 times 0.1 minus 12 times 0.1 squared. If I put that in the calculator, it will give me an answer of positive 0.28. So I know that this part will give me a positive gradient, so this part over here is increasing. And let's test another part which is to the right of 0.333, and that value could be 1. So y dash equals 4 times 1 minus 12 times 1 squared. So 4 minus 12 is -8. So this also gave me a negative answer. So I know that this part is decreasing. So from here, I can see that my function was decreasing, then increasing, okay? And then it kept increasing, and then it decreased again over at this second, after this second turning point. So my decreasing intervals, so my decreasing intervals are from -infinity up to 0, and from 0.333 or 1 over 3 up to positive infinity, and my function is increasing from 0 to 1 over 3. Let's take a look at another example. Let's say we have y equals 3x cubed minus 9x squared plus 10x plus 1. So let's start by getting the first derivative. This is going to be 3 times 3 is 9. 9x. 3 minus 2 is 2. 3 minus 1 is 2. Minus 2 times 9 is 18x. And then this is a plus 10. Let's equate this to 0. So this looks like it's quadratic. So I'm going to use the quadratic formula to solve. So I know that my quadratic formula is minus b plus or minus square root b squared minus 4ac over 2a. So minus b, so minus 18 plus or minus square root of minus 18 squared minus 4 times a, which is 9, times c, which is 10, over 2 times a, which is 9. So here I'll have an 18 plus or minus. Let's check what happens under the square root. This is over 2 times 9, so over 18. So we have an 18 squared, which is 324, minus 4 times 9 times 10 is minus 360. So I know that 324 minus 360 will give me a negative answer, and a negative cannot be square rooted. So basically, I have no solutions for this part over here. That means that there is no x value that will make my first derivative 0, indicating that my first derivative will never be 0, so I don't have a point where it's a critical point. Okay? This means that my graph never turns. It just either stays straight positive or straight negative, because if we had a turning point, it would become 0, and then maybe it could go up again or change its gradient. However, in this case, we don't have, and let's test this. So what I know is that this is a quadratic function. I know that I have no solutions, and I know that a is positive 9. It means that it opens upwards, and if it opens upwards, then it cannot start from here, since it from under the x-axis. If it opens upwards, then I will have two solutions. Since it opens upwards and I don't have a solution, then my quadratic function should be something like this. It should start above the x-axis, meaning that all the y values of this function over here, so all the y dash values or all the gradient values for this function is going to be positive values, indicating that my function is always increasing. And if I want to write the interval, it's going to be from negative infinity to infinity increasing. Hope this video helped. Hope you understood. Please don't forget to subscribe, like, and comment down below if you have any questions, suggestions, or anything you want to say. I will read them all and try to reply. Thank you so much for watching, and have a good day.